Green hydrogen will play a central role that extends far beyond its current position due to the increasing demand for decarbonisation. We will need hydrogen as a fuel in industrial processes, and it is considered a potent basis to store renewable energy. As a result, we will require thousands and thousands of electrolyzer cells and electrolyzers, and this need is imminent. I'm an optimist, but we really have to talk about whether it is feasible to scale up production to such high numbers in time, or if we are at risk of missing out on our planned future. Hello and welcome to our new episode of minus 253 degrees Celsius, the monthly expert talk that gets to the point, to the boiling point of hydrogen. And today I'm in beautiful Bamberg, where electrolyzer stacks are already being produced. And I'm joined by Christian Hymon, who's a senior manager in industrialization at Bosch. Christian, it's great to have you here.
Thanks for having me.
Let's start with the concern I mentioned in the intro. Will we have enough stacks when they are needed to make the transformation in time? And as far as I understand it, it's your job to make sure that it works. Is that right?
That's right. My job is industrialization. That means we bring innovations from a prototype phase to serious production. And this can really be considered as a big challenge because this time we have to start from scratch. Most of my colleagues, they have worked for industrialization of automotive products in the past. And this is more a evolutionary development because we have older generations where we can build on. For the electrolyzer stack, we consider this more as a revolutionary approach. Additionally, we have a very tight schedule, and with all these challenges, our answer is simultaneous engineering.
That's a term I've heard before, but can you explain a little bit about simultaneous engineering and the approach that takes? What are you guys actually doing?
Basically, we work in cross-functional teams to optimize the product design. This means, for instance, defining the product requirements, validation of concepts, definition of the product design, then also having the proper manufacturing value stream, finally validating and testing the product, and a lot more.
But what does it actually take to get a production-ready product?
Perhaps underestimated, it sounds easy, but actually it's a quite difficult job. Many of our tasks are driven by the question of how the product can be manufactured in the end. And this can lead to significant changes in the product design. We want to ensure the manufacturing can work stable with a consistently high quality every time we produce this electrolyzer stack.
Can you give us a little deeper insight? What components and parties do you actually have to consider when you industrialize electrolyzer stacks?
Our simultaneous engineering teams are set up according to our product value stream. In every team, we have people from product development. They design the product. From manufacturing, this is our part. We define the manufacturing processes, the machines, the tools, the infrastructure, the work routines. We feed back to product development what it needs to make it work. We have people from purchasing because all the parts that we don't produce in-house need to come from external suppliers. We have logistics. Our electrolyzer stack is a huge and heavy product. This is a new challenge also for them. We have people from quality management. They check the maturity of the product towards different milestones. And also in this specific case, we have TÜV because this stack is considered as a pressure vessel and therefore it requires a CE certificate.
Can you give us some example of what actually had to be adapted based on your findings during the industrialization process?
Some of our parts are extremely sensitive. That means that, for instance, even temperature or humidity needs to be controlled within a certain range already at the supplier during the entire transportation and also in our final assembly.
So it sounds like you're fully engaged in ramping up production as needed, is that right?
That's right. Currently, we still produce smaller number of stacks, but our processes are designed to scale up. We expect that the demands of electrolyzer stacks will multiply in the next years because we design processes and facilities that can adapt to changing market needs.
Despite the current challenges you face, are you able to foresee how things will have changed in the manufacturing of electrolyzer stacks by 2050?
Of course, we expect many changes in the next decades, and we will pay attention to this with every new generation that we will bring out in the market. Additionally, we already now have a very strong collaboration with our colleagues in Tilburg. They are in charge for the pre-development, and they, for instance, work on optimization of materials, like reducing catalyst loadings, means looking for alternative materials that are easier available or more sustainable. In terms of sustainability, already now we think about recycling concepts. Then we have the continuous improvement process. This is a fundamental part of our work. And finally, we also have the strong focus on data and artificial intelligence. That means even with the first stacks that we build, we collect tons of data for every single component from the suppliers in our in-house manufacturing, but also later on in the field.
Christian, I'm so glad you could join us today. My optimism is starting to scale and starting to ramp up because I now know that future needs are being well prepared for.
Thanks for having me.
And I want to thank you for joining us too for this latest episode of Minus 253 degrees Celsius, the expert talk that gets to the point, the boiling point of hydrogen. See you next time.